Hello, I'm Jürgen Miller, and this is my face centering filter project. The purpose of this project is to make a camera filter that will always center a face in a camera frame. The physical setup is the laptop webcam which you see me through now. The code will take a frame from that webcam, find the center of the face, and move the frame to center the face. It will then save that frame to video so I can watch it later. Here's the final result. You can see that as I move around the frame moves so that my face is always in the center. It can even keep up as I move around the frame a lot. To do this facial detection, I used OpenCV's Deep Neural Network framework. I imported a pre-trained model that's been trained to detect faces, and it would output if there is a face, and if so, I could get the confidence of the detection and the location of the face. Inside, this is using a convolutional neural network. Before passing it in, the image is normalized. This accounts for different image brightnesses. So if I turn off my lights or turn on my lights, my face can still be detected. Then the neural network has been trained to identify a face pattern. This is stored within the model weights, and you can see an example of a face pattern on the right here. You can see that it is detecting certain features that we often associate with faces, with eyebrows, nose, chin, mouth. The model architecture will convolve this pattern across the image. It will search all the areas of the image and different scalings of the pattern. Thus, we can detect a face anywhere at any scale in an image. The model is very good at detecting all human faces, but it will capture more than human faces, actually. Here, the model finds that there is two faces in the frame. On the left, that's me. It's 99% sure this is a human face and gives a bounding box for it. But it's also 99% sure that this picture of a log has a human face on it, because in the way it sees it, it has similar features to a human face, which I agree to a point. In the code, I set up the neural network once and pass each frame through the neural network. You can see here that the neural network is set up. The model, the architecture and weights are loaded from a file. Each frame is pre-processed and then passed through the network to give the detections. Here's a code diagram for the overall filter. At the beginning, I will open the webcam, set up the video, set up the neural network, and then in a loop, I will take a frame, and then with that frame, detect faces in it. This is done using the neural network, and I will then pick the most confident guess at what's a face, and then find the center of that face. I will then place the frame according to that face center and show the frame and save it to a file. The original camera frame is too big to pan around on my screen, so I shrink the camera frame to make a face frame, just a smaller version of that one. But then I need a frame that frame is able to pan around as I move. The video frame that I'm saving it in is twice as wide and twice as tall as the face frame. This means that even if face was at the exact corner of the frame, the whole frame is still shown, because there's space for the whole frame to be on that side of the image. It's important to note that faces can be detected close to the corners, but actually a face will never be detected at the absolute corner, because that would mean there's not enough face left to detect. You can see here that the face frame is up in the corner of the video frame because my face is down in the other corner. If multiple faces are detected in the image, the highest confidence face is picked. This will pick the most human face to focus the filter on. If no face is detected, the face frame is updated in the video frame, but it remains in the previous position. Here, I have an example of that. You can see as my face moves off the frame will stay in position and wait till it detects a face again. This can result in some jumpiness if the face is moved between those two times. To find the face center, the facial detection is done using the full-size camera frame. This uses the highest resolution image possible that improves the detection for far-away faces when they take up less pixels. The bounding box of the face is then converted to the center coordinates. This is just the average of each of the corners. But then I need to convert between frames, because I found the center in the full-size image, but then I scale the image to a smaller version to move around. The face center is converted from the camera frame to the face frame by using fractional scaling, and then the face frame is placed on the video frame to center the face, and it's spliced into the video frame. This means that the frame will move around to always keep the face in the center. Here again shows that once everything is set up, we can take the frame, detect the faces using the neural network, pick the most confident face, find the center of that face, place the frame according to that center, and then show that frame and save it to file so we can watch it. Here again is showing what this all looks like. Thank you.